So let's back up a minute and talk about what we did on Monday. That was a long time ago. Because we found critical points. That was where f prime was 0 or f prime is undefined. And that was sort of our set of possible extrema. Right? Because all extrema are critical points, but not all critical points are extrema. On Monday, and on the quiz on Monday, we used a table of values to find the absolute extrema. Right? We just, whichever one's the biggest is the max, whichever y value is the smallest is the min. But we would like to have a method to figure out the relative extrema, the local extrema. And the table of values doesn't really do that because it only gives you 1 point, so you're not really sure if that's like the top of a hill, or the bottom of a valley. So the method we'll use today to locate the relative extrema is the first derivative test. So that's sort of where it fits in big picture. So this top path was lesson 3.1 from Monday. Critical points are possible extrema, put them on a table of values. Today is going to start the same way. We'll find the critical points, but then we're going to do this first derivative test thing. And we don't know what that is yet, but this is sort of the big picture roadmap of what we did Monday versus what we're doing today. And you can kind of see what they land at different places. All right, let's make sure we understand a little bit of background of first derivative before we do the first derivative test. So I think you know this, but what does the first derivative tell us about the graph of f? Slope of a tangent line. And sometimes we're lazy and don't say of a tangent line, although we should say it every time. But it's the slope of f at a point, as much as that's possible. So yeah, technically we mean slope of a tangent line at a point. So that means if f prime is greater than 0, f prime greater than 0, f prime equal to 0, let's figure out what that means in terms of f. So if f prime is greater than 0, if f prime is positive, what does that tell us about f? We haven't really done this, so I think it's going to make sense once I say it, but you might not be able to know what word I'm thinking of. What's the graph of f doing if f prime is positive? What's that? It's like, what'd you say? Ascending. That's a great word. The word we use in calculus is increasing, but ascending means the same thing. If f prime is positive, we're going up. We're increasing, we're ascending. Yes. If f prime is negative, we're descending, we're going down, we're decreasing. And if f prime is 0, what's that look like? Yeah, some horizontal tangent line, but that would mean f is constant. Now, be careful. It doesn't mean it's constant forever. It means it's constant at that moment. So, like, just for the moment there, f isn't changing. But that's sort of the key. That's where we find our critical points, because it might be a max or a min there. All right, this idea is huge. If you remember that, that's going to sort of take you through the first derivative test, as well as quite a bit of stuff in calculus. F prime means F is increasing. F prime negative means F is decreasing. So let's use that information. Let's find critical numbers. We already know how to do that. And, so this will be the new part. Find critical numbers and increasing and decreasing intervals. So find critical numbers, we know how to do that. F prime is 0 or undefined. That'll sort of set up the intervals, and then we'll figure out, well, between those intervals, what's F prime, because if F prime is positive, then we're increasing. If F prime is negative, we're decreasing. So we're adding like one extra step to what we did Monday. All right, f of x equals 1/3 x cubed plus 2x squared minus 12x plus 3. That looks kind of bad with the 1/3, but when we take a derivative, I'm being nice to you here, that would be x squared plus 4x minus 12. So unlike number 11 from 174 that didn't factor and we had to use quadratic formula, this one will factor. So x plus 6 and x minus 2. So x equals negative 6 and x equals 2. Those are our critical points. That was sort of it for the first part of Monday's lesson was, hey, just find critical points. Let's make sure we understand what those are. So we found them. Now, those are the only places where f prime is 0. So we're going to set up a number line with negative 6 and 2 as sort of the breakpoints for our intervals. And we want to know, well, we want to know what f is doing. Is it increasing or decreasing? How we'll know that is what f prime is doing. And so we need to test a point from each interval. Hence the first derivative test. That's the name of the unit or the lesson, is pick a number from each interval, test it into the first derivative. So negative 7. What's a great number to try between negative 6 and 2? 0. How about a number bigger than 2? 3. Or 7 or 12 or 500, but usually go with something easy. Now, we want to test that into the first derivative because the first derivative will tell us if we're ascending or descending, if we're increasing or decreasing. I have two expressions for f prime up here. I have one that's not factored and one that is factored. Now, they're equal, so I can use either one, but I think the factored one is going to be easier to use because all I really want to know is if f prime is positive or negative. So I'm going to use the factored form, and it kind of depends on the problem which one's easier, but for this one I think the factored form is easier. So negative 7 plus 6 times negative 7 minus 2. And all I really care about is positives and negatives, so I'm not super concerned with getting the value right. So we get a little lazy or efficient, would be a better way to say it. Negative 7 plus 6 is negative. Negative 7 minus 2 is negative. And negative times negative is positive. So f prime is positive. What does that tell me about f then? It's increasing. So f is increasing. Some people will write the word increasing. Some people will do an arrow to just kind of show the general direction of the graph. Some people will do both. Either one's fine. I will probably always do both to accommodate whatever your preference is. So f is increasing up to -6. Between -6 and 2, well, I don't know. Let's plug in 0 and see what happens. So 0 plus 6 times 0 minus 2 is positive times negative, which is negative. If f prime is negative, what does that tell me about f? Decreasing. Or you could just draw a down arrow to kind of just get the general shape of the graph. Plug in 3. 3 plus 6 times 3 minus 2. Positive times positive is positive. So that would be increasing. Now this roughly, very roughly, but roughly sketches out the shape of this graph. So we increase up to -6, and we decrease till we get to x equals 2, and then we're increasing after that. Does that fit with what you know about what an x cubed looks like? Right, we did one that you kind of know what x cubed looks like. I mean, we'd have to get a table of values to get it exact, but it generally looks like that. So this sort of fits: increasing, decreasing, increasing. It's nice when you have a function that you sort of know what it looks like to verify your answers. So be careful. Yes, x squared is a parabola, but that's the derivative. The original function is a cubic. So increasing, decreasing, increasing. So let's back up. What did this question want me to find? Find the critical numbers. Found that. Increasing and decreasing intervals. Okay, well, there they are, but I need to sort of state that better than just say, oh, there's my picture. We'll say it's increasing from -infinity to -6, and then from 2 to infinity, and it's decreasing from -6 to 2. And we don't want to include any of those endpoints, because at -6 and at 2 is when f prime was 0, so it's not increasing or decreasing. Good with that? So critical points, we know how to find those. Now we've added this extra step about, well, what's going on in between the critical points? Are we increasing or decreasing? Now we'll use that picture in our first derivative test. So here's the big deal for today, the first derivative test. I bet you could fill in these blanks, so I'll let you try. If f prime changes from negative to positive at x equals c, then f of c is a copy it down first and then think about what you wrote. If f prime changes from negative to positive, then f of c. So if f prime changes from negative to positive, like think in your brain or even do it with your hand, f prime changes from negative to positive, what's happening then? If we're changing from negative to positive at this spot right here, what would you call that point? What's that? It is a critical point. Be more specific. You're right. It's a minimum. It may be a vertex, but depending on the shape. So if it's a parabola, yeah, it's a vertex. But more generally speaking, it's a relative minimum. That's not one, I don't think you memorize that. I think you think about that when you see it. F prime changes negative to positive. Yeah, that's a minimum. And so we'll be doing this all year, and you'll see me thinking out loud with my hands. Yeah, that's a minimum. You can guess what the other one's going to be. If F prime changes from positive to negative at x equals c, F prime changes from positive to negative. F prime is the slope. So the slope goes from positive to negative. So what's going on if we change from going positive to going negative? What's going on? What do we have? A relative maximum. We're at the top of a hill. So our job today is to locate the relative mins and maxes. And we'll do that. We didn't do it on this problem we just did, but we were set up to do it on the problem we just did, because especially the way we showed everything. What's going on at negative 6? The relative maximum, because we change, F prime changes from increasing to decreasing. Or no, excuse me, F prime changes positive to negative. What's going on at x equals 2? There's a minimum, because F changes decreasing to increasing. F prime changes negative to positive. Be careful, make sure you use the right words there. I almost messed that one up. So let's do one example where we kind of find everything all the way through. We've done the pieces. Now let's find the relative extrema of f of x equals x squared minus 4 to the 2/3. You don't need to write this again, but maybe it helps to see it again. Critical points lead to possible extrema. Monday we did a table of values to get the absolute extrema. This is exactly what I wrote earlier. Today we're doing the first derivative test to find the relative extrema. So that's sort of the big picture roadmap of the first couple sections of this chapter. So today we're taking this route. That's the section 3.3 route. Section 3.1 was with the table for absolute extrema. So they start out the same way. Find the critical points, and that leads us to some possible extrema. So f prime of x equals, oh, this one's kind of yuck, 2/3 x squared minus 4 to the negative 1/3 times, what else do I need to include in this derivative? 2x. Good. Chain rule. So let's clean this up a little bit. I got a 2x and a 2 in the top, so that would be 4x. In the denominator, there's 3. But this negative exponent will also send this other piece to the bottom. So I'll have x squared minus 4 in the bottom. What's a power of 1/3? I'm trying to do all my algebra steps at once here. That's a cube root. The 1/3 power is the same as a cube root. So I've got a cube root in the denominator. Alright, so job 1 is to find critical points. That's where f prime equals 0, or where f prime is undefined. I probably shouldn't say equals undefined, but you know what I mean, where f prime is 0 or is undefined. So what would make my derivative equal to 0? What value of x would make my derivative 0? Uh-oh. Well, first, are we looking at the top or the bottom? The top. The top would make a fraction 0. So x equals 0. All right, divide both sides by 4. It's early. What makes a derivative undefined, or what makes a fraction undefined, I should say? A 0 of the bottom. So I need to figure out what makes all of that equal to 0. Now, some people can look at that right away and come up with the two answers. Other people are going to do some more algebra steps to get there, like divide both sides by 3. So I'll do the algebra steps, although I hope some of you can look right away and see what makes that 0. Cube both sides. And then you could factor it, you could move the 4 over, but enough of showing my algebra steps. What values of x make the bottom 0? 2 and negative 2. So now I've got my critical points. 0 plus or minus 2. Okay, these are long problems. This is why I wrote the roadmap up there. Critical points. For this problem, found them. 2 and negative 2. Those are possible extrema. Now I'm going to do the first derivative test. So that's set up a number line and figure out increasing, decreasing for maxes and mins. Please make sure you put your critical points on the number line in order. Right? Like that makes, I mean, it's a horrible mistake to get back and realize that you wrote a number line where 0 is greater than 2 or something like that. Like, it's frustrating for me, frustrating for you. All right, so that sets up our intervals. So we need to test some points into f prime because that will tell us increasing or decreasing. So back up here, can't even fit it all on the screen at once. So I circled f prime because that's what I'm going to be plugging into. Now it looks ugly, but again, all I'm really concerned about is positives and negatives. So yeah, cube root and an x squared, we'll see. So if I plug in negative 3, I guess I'll do it the official way to start with, and then we'll see where we can kind of shortcut this stuff. So I plug in negative 3. And again, all I care about is positives and negatives. So if all I care about is positives and negatives, what's 4 times negative 3? Negative. Good. In the bottom, 3 doesn't matter. 9 minus 4 is 5. I have no idea what the cube root of 5 is, except that it's positive. So f prime is negative. What does that tell me about f? It's decreasing. I said I was going to write it and do the arrow. I think I prefer the arrow because it visually shows me what's going on with the function. All right, plug in negative 1, get the next interval. Goodness, at this point I could just leave off that 3 that's out front because that doesn't change the sign of anybody. So negative in the top for sure. Let's see, if I square negative 1, I get 1. 1 minus 4 is negative 3. What's the cube root of negative 3? For our purposes, negative. I have no idea what it is, but I do know that it's negative. So negative over negative is positive. So that if f prime is positive, that means f is increasing. Plug in 1. 4 times 1 over 3 times cube root of 1 squared minus 4. 4 times 1 is positive. The cube root of 1 minus 4 is negative. If f prime is negative, that means f is decreasing. Based on patterns in all of 2 problems that we've done, you want to guess what the last interval is doing? Positive, but let's make sure you're right. Everything's positive, so yeah, it's positive. F prime is positive, that means f is increasing. Again, be careful, don't just say it's positive or it's decreasing. You have to be specific. All right, I keep going back to what was the point of this problem now. Find the relative extrema. Back to our roadmap. Critical points lead to possible extrema. We just did the first derivative test. Now let's make some conclusions. So what's going on at x equals negative 2? And how did you know that? Okay, yes, but what goes from negative to positive? You got to be specific. What goes from negative to positive at x equals negative 2? The slope, so is that f or f prime? F prime. So f prime changes negative to positive. We're going to use that line a lot. That's our justification for a relative minimum. F prime changes negative to positive. Since we've got it all written out, are there any other places that have a relative min? That way we don't have to write all of this again. We can just say at x equals negative 2 and x equals any other relative mins? Careful, the only values our critical points are these. So at x equals 2, it changes that same way, and there's a minimum. Again, the arrows I think are helpful because they're more helpful at visualizing. So at x equals 2 and negative 2, there's a relative min because f prime changes negative to positive. Yep, you could. All right, do we have any relative maxes? At x equals 0, there's a relative max because, what's my reason going to be? F prime changes positive to negative. Again, those are always going to be linked, but you don't really memorize them, you just think about them. If f prime changes positive to negative, that's a max. If f prime changes negative to positive, that's a min. So I guess some people memorize them, but I never thought it's worth it. Like, just think about it. All right, the assignment's page 183, 7 to 43 odd, 63 to 69 odd. Let's put it on here. Monday we'll have a quiz, but we'll also have no new notes. So it's kind of a catch-up day, work some problems day. So do some of them before Monday, but you're not getting any additional homework on Monday. So if you only want to do half of them and save half for Monday, that's fine. although it's the weekend, so you could knock them all out and then not have any calculus homework Monday. I leave it for you to manage your time as best for your situation, but I would definitely do some before Monday. That way, when we're going over them, you understand if you got it or if you don't got it. So that's why that will free us up to have some time for a quiz. I know that excites you.